This is SpaceTime, Series 21, Episode 52. Coming up on SpaceTime, complex organics bubbling up from deep below the surface of Enceladus, the possibility of new forms of quark matter, and the end of the Australian Astronomical Observatory. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Large complex organic molecules have been discovered in the geysers spewing out of the Saturnian ice moon Enceladus. The findings, reported in the journal Nature, support the hypothesis that the subsurface liquid water oceans below Enceladus's frozen crust host conditions suitable for life. The observations were made by NASA's Cassini spacecraft as it studied the plumes of water vapor and ice crystals jetting out through deep cracks known as tiger stripes at the 500-kilometre wide moon's south pole. Mineral salts in the plumes support the idea that hydrothermal seafloor vents are mixing up material from the moon's water-filled porous rocky core with water in the moon's global subsurface ocean. The Enceladian vents, similar to hydrothermal vents along Earth's mid-ocean ridges, were postulated following the detection of molecular hydrogen during earlier passes through the plumes by Cassini. Molecular hydrogen in the plumes are thought to form through the geochemical interaction between water and rocks in the warm hydrothermal environments. Its discovery is important because hydrogen provides a source of chemical energy supporting microbes that live in Earth's oceans near hydrothermal vents. Also, it's not the first time Cassini's detected organic molecules at Enceladus. However, those earlier detections involved much smaller, more common organic molecules. But these new discoveries by Frank Postberg and Noje Kawaja from the University of Heidelberg identified fragments of far larger, more complex organic molecules. Postberg says it's the first ever detection of complex organics coming from an extraterrestrial water world. In fact, complex molecules comprising hundreds of atoms are rare beyond Earth. One of the study's co-authors, Christopher Glenn, from the Southwest Research Institute in San Antonio, Texas, says the organic molecules now detected have masses above 200 atomic mass units. That's over 10 times heavier than methane. These huge molecules contain a complex network, often built from hundreds of atoms of carbon, hydrogen, oxygen, and possibly also nitrogen, forming ring-shaped and chain-like substructures. With complex organic molecules emanating from its liquid water ocean, Enceladus is now the only body apart from Earth known to simultaneously satisfy all the basic requirements for life as we know it. The presence of large complex molecules, along with liquid water and hydrothermal activity, supports the hypothesis that the oceans of Enceladus may well be a habitable environment for life. You see, such large molecules can be created by complex chemical processes, including those related to life, but just as easily they can be primordial material in some meteorites. The important difference is, at Enceladus, it's most likely that they came from hydrothermal activity during complex chemistry in the core of the moon. The rich chemical soup found around Earth's hydrothermal mid-ocean vents has long been speculated as a likely site for the emergence of life. On Enceladus, bubbles of gas rising through kilometres of ocean could be bringing up organic material from the depths, where it could form thin films floating on the ocean's surface and in cracks associated with vents in the interior of the moon just beneath the icy shell. So after rising to the top of the ocean, these bubbles may burst or otherwise disperse the organics, which were then detected by Cassini. Prior to its deorbit in September 2017, Cassini sampled the plumes of material emerging from the subsurface of Enceladus, as well as those from Saturn's E-ring, which is also formed by plume ice grains escaping Enceladus's gravity. You're listening to SpaceTime. I'm Stuart Gary. A new study has resolved a long-standing mystery, finding that neutron stars could be no more than around 12 to 13.5 kilometres wide. The findings, reported in the journal Physical Review Letters, are based on comparisons of billions of theoretical models with gravitational wave results. Previously, estimates on the size of neutron stars varied from 8 to 25 kilometres. And that's resulted in the use of fairly generalized non-specific terms, such as neutron stars being the size of cities. Neutron stars are the densest known objects in the universe other than black holes. In fact, just a teaspoon of neutron star matter would weigh more than Mount Everest. They're created through the death of stars at least 8 times more massive than the Sun in spectacular core-collapse supernova explosions, bright enough to briefly outshine an entire galaxy. For over 40 years, the determination of the size of neutron stars has been a holy grail in nuclear physics. And solving the question will provide important information on the fundamental behavior of matter at nuclear densities. At the end of 2017, Luciano Rozzola from Goethe University in Frankfurt used data from a gravitational wave event known as GW170817, which involved the merger of 2 neutron stars to form a stellar mass black hole, to finally determine the maximum mass a neutron star can support before collapsing to form a black hole. We now know that's around 2.16 solar masses, but you can add up to 20% more to that figure depending on stellar rotation. Now, as we found out last week, the problem is the equation of state which describes matter inside neutron stars is not known, meaning determining the maximum size of a neutron star is still out of reach. To try and resolve the issue, Rozzola and colleagues therefore decided to pursue a different path, instead selecting statistical methods to try and determine the size of neutron stars within narrow limits. In order to set the new limits, they computed more than 2 billion theoretical models of neutron stars by solving the Einstein equations describing the equilibrium of these relativistic stars, and then combined this large data set with the constraints coming from the GW170817 gravitational wave detection. This allowed the authors to determine the radius of a typical neutron star to within a range of about 1.5 kilometres, finding it to lie somewhere between 12 and 13.5 kilometres, a result which will undoubtedly be further refined by future gravitational wave detections. However, there is a twist to all this. That's because neutron stars can have twin solutions. You see, it's possible that at really high densities, matter can drastically change its properties undergoing phase transition. It's similar to what happens to water when it freezes and transitions from a liquid to a solid state. In the case of neutron stars, this transition speculated to turn ordinary matter to quark matter, producing stars which would still have the same mass, but would be much smaller and consequently far more compact. Rozzola and colleagues say their calculations suggest that quark stars would be statistically rare, and future gravitational wave observations will undoubtedly further refine these data. I'm Stuart Gary. You're listening to SpaceTime. There's growing speculation in physics about the possibility of new forms of matter existing beyond the periodic table, creating a sort of continent of stability composed of exotic quark matter. When you look at the periodic table, there's a strong trend for elements to increase in instability as they get more massive. In other words, the more protons and neutrons in the nucleus of an atom, the less stable that atom becomes. That's why some of the heaviest atoms recently created can exist for only a few seconds or even fractions of seconds before decaying into progressively more stable atoms. Currently, the most massive element on the periodic table is organosine, which is an atomic number of 118 and the chemical symbol Og. Organosine was first synthesized in the laboratory in 2002 and achieved formal recognition in 2016. Its most stable isotope, organosine-292, has a half-life of just 0.89 milliseconds before it decays into livermorium-290 through alpha decay. In fact, it's so unstable only 5 or 6 atoms of organosine have ever been created. This predictable steady decline in atomic lifetime versus mass has led some physicists to predict the existence of a possible island of stability, a region beyond the existing periodic table, where the numbers of protons and neutrons can reach some sort of magic level of stability. Mind you, it's never been found, but as we've reported previously on Star Stuff, there have been several hints. Now, a report in the journal Physical Review Letters claims that rather than protons and neutrons, it's the quarks inside them which could provide new combinations of exotic particles in this island of stability. Protons and neutrons are each composed of 3 quarks, either 2 up quarks and a down quark, or 2 down quarks and an up quark. There are at least 4 additional types of quarks which have been discovered through particle accelerators, known as top, bottom, charm, and strange. These are commonly found in extreme environments such as neutron stars and make up what scientists call quark matter, but let's leave them aside for the moment. This new study by researchers from the University of Toronto suggests that if enough up and down quarks were massed together, they would preferentially form an energy state low enough to create an exotic type of stable matter known as up-down quark matter, or UDQM. The result would not be the islands of stability proposed through super-heavy atomic matter, but a continent of stability composed of up-down quark matter. And that's really interesting, because according to the maths, it'll be difficult to create anything other than up-down quark matter once atomic mass reaches around 300, meaning that at 294, organicin may well end up being the last element ever found on the periodic table, because the table would be complete. The discovery of up-down quark matter would open a whole new horizon of physics, allowing researchers to study quark color superconductivity, or as a usable gamma radiation energy source. Something I'm sure Steve Banner's working on right now. You're listening to SpaceTime. I'm Stuart Gary. The Australian National University has taken the lead role in a new consortium of 13 universities, which are taking over the operations of the Australian Astronomical Observatory. The AAO, as it's affectionately called, was originally set up in the 1970s as an independent body to oversee the then newly constructed 3.9-metre Anglo-Australian telescope, built following a push during the 1950s and 60s for a large optical telescope in the Southern Hemisphere. The telescope was built as a joint Australian-British science facility on the grounds of the Australian National University's Siding Spring Observatory, and formally opened in 1974 as the Anglo-Australian Observatory. And since first light, it's had an illustrious scientific career. In fact, between 2001 and 2003, it was considered the most scientifically productive 4-metre class optical telescope in the world, based on scientific publications using data from its observations. And even as recently as 2009, the telescope was ranked as the overall 5th highest impact optical telescope on the planet. It was renamed the Australian Astronomical Observatory in 2010. Now, a major restructuring effort by the federal government sees Australian Optical Astronomy becoming a partner in the European Southern Observatory's giant 8-metre VLT telescopes in Chile. And that's led to the decision to migrate the AAO to a consortium of universities and scientific institutions. As well as the Australian National University, the other institutions of the consortium include the University of New South Wales, University of Sydney, Macquarie University, Western Sydney University, the University of Melbourne, Swinburne University, Monash University, the University of Queensland, the University of Southern Queensland, Curtin University, the University of Tasmania, and the University of Western Australia. The director of the Siding Spring Observatory, the ANU's Associate Professor Christopher Lidman, says the facility's work will continue.
The AAO, as part of a big transition in Australian astronomy, is going to be split into two. The AAT will be operated by a consortium of Australian universities. That's made up of 13 Australian universities. That's one half. The other half, which is the part of the AAO which develops instruments, is going to another consortium of 3 Australian universities. So the bits and pieces of the AAO continue, but the AAO as a whole, as it is now, will cease to exist.
And of course the most valuable part of the AAO were the minds, the geniuses who did the research and developed the technology. What happens to the staff?
Absolutely. So they will continue on in these 2 new organisations. So the staff at the AAT will continue to work at the observatory up there near Coonabarabran, and the staff who developed all the instrumentation for the AAT and some of the larger telescopes overseas will also continue, but will now be based at Macquarie University.
The dawning of a new age for Australian astronomy.
It is. It's perhaps the biggest change in Australian astronomy over the last 45 years. Part of a bigger picture. The bigger picture is that Australia is now a partner in the European Southern Observatory. That was signed last year. And the splitting of the AAO into these 2 new organisations, part of that bigger story. So it's a positive story because Australian astronomy, as optical astronomy, has grown quite significantly with these changes.
There's still that dichotomy between optical astronomy and radio astronomy, with the CSIRO still doing its thing. That's not an issue, that's not a problem?
No.
Because often these days astronomy overlaps. I mean, you may be doing optical astronomy, but yeah, there are some things you want to look at they can only see in radio or in infrared, or these days I guess gravitational waves as well.
Absolutely. It really is the era of multi-messenger astronomy. No longer are we looking at things in terms of photons, but also gravitational waves. These linkages that you mentioned, both within the AAO and CSIRO will continue. So there's a lot of astronomers who use both facilities, both radio waves and optical photons and infrared photons for that matter, to do their research.
So how's all this being seen by researchers?
I think it's very positive. I think Australian astronomers have obtained what they've really sought for, I guess, the last 30 years. I remember when I was doing my PhD early in the 1990s, there was an opportunity to join the European Southern Observatory back there, but we failed at the very last hurdle. And we've been wanting to join this organisation for as long as I've been an active astronomer, so it's really, really great news. And the fact that we also get to keep the AAT and Siding Spring Observatory going means it's really just a win-win for everybody from the researcher's point of view.
So what is the long-term future of the Siding Spring Observatory?
Well, that's a very good question. I think to answer that, one has to look at the reasons why the observatory was established there in the first place. And the reasons being, of course, being in the southern hemisphere, it had that wonderful access to the southern skies. It's also located at a very dark site. So there's a couple of reasons why the observatory was established there some 50 years ago. And the question to ask now, why would you want to continue observing there? And the reasons are very similar. It's still located in the southern sky, and so you have access to the southern sky. It still remains a very dark site, and so it's excellent for that. But there are other reasons now why you want to continue at Siding Spring. It's an excellent place to train the future generation of astronomers. It's also an excellent place to bring up novel instruments to test before you bring them to the larger telescopes overseas. But probably more important now is that the longitude of the observatory means that it's well positioned to follow up transient phenomena which are discovered elsewhere. So, for example, when the sun rises in Chile and the astronomers have finished their work for the night there, the sun's setting in Chile, in Australia, sorry. And so you're in a prime position to follow transient phenomena. And with the advent of telescopes like the Large Synoptic Survey Telescope, which has been linked to discover thousands and thousands of transient, Siding Spring really is just in the prime position to follow up these objects once they're discovered in Chile or elsewhere. So in a sense, the reasons for having an observatory there are even more compelling now than they were 50 years ago. So I think the future for Siding Spring is very positive.
That's Associate Professor Chris Lidman from the Australian National University. I'm Stuart Gary. This is SpaceTime. US President Donald Trump has formally ordered the American military to begin the process of creating a United States Space Force. The move is in direct response to the growing military space presence of both Russian and Chinese forces. The announcement, made at a meeting of the National Space Council, comes despite strong recommendations that any US Space Corps should be part of the existing US Air Force, which currently has responsibility for military space operations through the US Air Force Space Command. Moscow also runs its military space operations as a branch of Russia's existing Air Force. The Pentagon has been working to improve coordination between America's 5 existing armed forces branches: the Navy, the Army, the Marines, the Air Force, and the Coast Guard. It says it will work with Congress and other stakeholders to move forward with a new policy, which will have implications for intelligence operations for the Air Force, Army, Navy, and Marines. The new branch's creation will be overseen by General Joseph Dunford, who's chairman of the Joint Chiefs of Staff. Meanwhile, NASA says it strongly supports the move, which it says forges a sustainable and focused space policy, strengthening America's leadership. President Trump says the new 6th branch of the military will be a separate but equal entity to the US Air Force.
My administration is reclaiming America's heritage as the world's greatest spacefaring nation. The essence of the American character is to explore new horizons and to tame new frontiers. But our destiny beyond the Earth is not only a matter of national identity, but a matter of national security. So important for our military, so important, and people don't talk about it. When it comes to defending America, it is not enough to merely have an American presence in space. We must have American dominance in space. So important. I'm hereby directing the Department of Defense and Pentagon to immediately begin the process necessary to establish a Space Force as the 6th branch of the armed forces. That's a big statement. we are going to have the Air Force and we are going to have the Space Force, separate but equal. 1 year ago, I revived the National Space Council and put exactly the right man in charge, and that's our friend, Mike Pence, feels very strongly about this. And in December, I signed a historic directive that will return Americans to the moon for the first time since 1972. This time, we will do more than plant our flag and leave our footprints. We will establish a long-term presence, expand our economy, and build the foundation for an eventual mission to Mars, which is actually going to happen very quickly. And, you know, I've always said that rich guys seem to like rockets. So all of those rich guys that are dying for our real estate to launch their rockets, we won't charge you too much. Just go ahead. If you beat us to Mars, we'll be very happy and you'll be even more famous.
United States President Donald Trump. And this is Space Time. I'm Stuart Gary. A Dragon cargo ship carrying some 2,676 kilograms of scientific experiments, cargo and equipment has safely docked to the International Space Station. The SpaceX Dragon CRS-15 blasted off 2 days earlier from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida aboard a Falcon 9 rocket.
Stage 2 launch is closed out for flight.
Stage 2 liquid oxygen closed out for flight, signifying a good liquid oxygen load. Next major milestone, the autonomous flight termination system will be checked and termed ready for launch.
Gas coolers have started. Vehicles in startup.
Falcon 9 is in startup mode. Flight computer is making its final pre-launch checks. Propellant tanks are
go for launch.
Flight pressure, and as you hear, Launch Director Mike Taylor gives go for launch of today's SpaceX CRS-15 mission.
Gas closeouts complete.
The pad deluge water system will be activated at T-minus 18 seconds.
Stage 1 tanks pressing for flight.
T-minus 15 seconds.
Everything is go.
10, 9.
T-minus 8 seconds. 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff. The Falcon 9 rocket powers the Dragon spacecraft toward the International Space Station, laden with new research for the multinational crew.
Visual prop is nominal. Vehicle is pitching down.
After liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through the area of maximum aerodynamic pressure, or max Q. This is the point
Power and telemetry nominal.
when mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by the Earth's atmosphere.
Confirmation that the Falcon 9 is supersonic. Contrail as the rocket passes through maximum dynamic pressure.
Vehicle has reached maximum dynamic pressure.
At around 2 minutes 35 seconds into the flight, all 9 engines will sequentially shut down and you'll hear the call MECO, which is main engine cutoff.
MVAC engine chill.
The MVAC is the second stage Merlin vacuum engine. It's being chilled for its operation, which will get underway in a little bit more than 30 seconds. Standing by for main engine cutoff.
MECO.
Stage separation confirmed.
MECO and stage separation confirmed. The first stage of the Falcon 9 rocket, having done its job, falls away from the second stage.
MVAC ignition.
MVAC ignition. The Merlin vacuum engine has ignited.
Stage 1 AFTS is safe.
The MVAC engine and the second stage will burn for about 6.5 minutes, bringing Dragon into low Earth orbit.
Both the Falcon 9 and the Dragon capsule used on this mission had flown previously. The Dragon was used on CRS-9 back in 2016, while the Falcon 9 flew just 10 weeks ago, launching NASA's test spacecraft. The flight also marked the final launch of a Block 4 version of the Falcon 9. All future missions will now use the new Block 5 versions. The CRS-15 manifest included some 205 kilograms of provisions for the crew aboard the space station, 190 kilograms of space station hardware and equipment, 21 kilograms of computer equipment, and 63 kilograms of hardware for future extravehicular activities, spacewalks. Also aboard were some 1,233 kilograms of scientific experiments. These include the Chemical Gardens experiment, which will examine how microgravity affects the growth of complex silicon-based structures. These structures are formed from the interaction of metal salts with silicate anions. Also aboard is the Earth Sensing Imaging Spectrometer, a high-resolution camera developed in part by Melbourne's La Trobe University, which will be attached to the outside of the space station for the next 4 years, monitoring wildfires, the health of the Great Barrier Reef, measuring water quality, the runoff of pollutants, and detecting the illegal dumping of chemicals. NASA's eco-stress research payload will also be mounted on the outside of the orbiting outpost. From its perch, it'll monitor the temperature of plant life on Earth's surface and how ecosystems respond to the amount of available water and the resultant impact that has on the carbon cycle. Other experiments will examine microgravity's effect on the microbiota in the gastrointestinal tract for long-duration space travel, as well as improve the treatment of gastrointestinal, immune system, metabolic, and sleep disorders on Earth. Another experiment studying cancer therapies will look at designing safer drugs targeting the vasculature of cancer tumours. Then there's Simon with a C, the European Space Agency's crew interactive mobile companion. Simon is a basketball-shaped artificial intelligence based around IBM's Watson system. It's designed to support astronauts aboard the space station, assisting with checklists, experiments, and providing instructions through a voice interface that allows crews to keep their hands free for other tasks. Simon uses a series of small onboard fans to maneuver autonomously through the space station. It has ultrasonic sensors and cameras for collision avoidance and has microphones and speakers to interact with the crew. And just like the HAL 9000 from Arthur C. Clarke's 2001 A Space Odyssey, Simon can monitor the psychological condition of its human crewmates. Luckily for the astronauts aboard the space station, there are no pod bay doors to control.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
Also aboard the Dragon CRS-15 are new varieties of food plants to be grown aboard the space station to see how they cope in microgravity. These ones were selected by Florida school kids for their taste and compact size, one of the advantages of living in a country with an advanced space program. The flight also sent up a replacement LEE, or latching end effector. Basically, it's a new manipulator for the space station's Canadarm2 robotic arm. The robotic arm is fitted with one of these end effectors at each end of the arm, allowing it to move between different base points around the outside of the space station in order to reach, grapple, and manipulate external hardware. It's also used to provide a supporting base for astronauts on spacewalks and to grab and dock spacecraft not fitted with automated docking systems. Dragon will remain attached to the space station for around a month before returning to Earth with completed experiments and supplies. I'm Stuart Gary. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found that the coldest place on Earth is even colder than previously thought. Back in 2013, scientists identified the coldest place on the planet on a high ridge on the East Antarctic Plateau, where temperatures in several hollows dipped below minus 92 degrees Celsius during the southern polar night running through July and August. Those observations were based on data from the joint NASA-US Geological Survey Landsat 8 remote sensing satellite. But the new measurements, reported in the journal Geophysical Research Letters, have found the area to be even colder than originally thought, with temperatures dropping down to minus 98 degrees Celsius on clear winter nights. Australia has placed a $7 billion order for Northrop Grumman MQ-4C Triton unmanned maritime surveillance aircraft. Based on the Global Hawk UAV, the Triton features heavier airframe, reinforced wings, and stronger landing gear. It also features de-icing and lightning protection systems, allowing it to descend through cloud layers to gain a closer view of ships and other targets at sea. Triton will work alongside the Air Force's new Boeing P-8A Poseidon maritime surveillance aircraft, which are now coming online to replace aging AP-3C Orions. Canberra's interest in the Triton can be traced back to 2001, when a US Air Force Global Hawk completed a non-stop 23-hour flight from Southern California to South Australia. Australian Defence was so impressed they began collaborating with the US Navy for a maritime version of the Global Hawk, and hence the Triton was born. The high-altitude, long-endurance aircraft will be used for maritime patrol and surveillance missions up to 24 hours in duration, using an advanced sensor suite that provides a 360-degree view of its surroundings for over 2,000 nautical miles. Images of an Australian cockatoo have been discovered in a manuscript dating from 13th century Sicily, now held in the Vatican Library. The findings, reported in the Paragon Journal, reveals that trade in the waters in and around Australia's north was flourishing as far back as medieval times. Scientists say the trade routes across the top end must have linked across the Arafura Sea to the Indonesian archipelago, then on to China, Egypt, and beyond into Europe. The fearsome Thoracosaurus, a dinosaur-era reptile from North America with jaws like giant pincers, bears an uncanny resemblance to a modern-day fish-eating crocodile called the gharial. However, new research led by Flinders University shows these similarities are in fact another example of convergent evolution, where two creatures end up looking similar even though they're not directly related, a characteristic which has repeatedly fooled scientists trying to reconstruct the family tree of crocodiles. The study is reported in the Journal of the Proceedings of the Royal Society B. New Caledonian crows already have a reputation for being extremely clever, but new research has found that these birds can memorize how to make tools. The findings, published in the journal Scientific Reports, shows that certain tool designs seem to have stuck around in certain crow populations, suggesting crows are passing on the tool design through observation and memory. The intelligence of New Caledonian crows was first brought to the public's gaze when the birds demonstrated their problem-solving abilities by working out how to get food floating on the surface of water inside a half-filled narrow-neck bottle. After studying the problem, the crows simply began dropping pebbles into the bottle to raise the water level until they could reach the food inside with their beaks. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.